welcome to Think Academy. I'm your math teacher, Mumu. Is Mumu pretty? Yes, it's very stylish, colorful, and flowery. But wait, what are you talking about? I'm talking about this long, colorful dress. It's also called Mumu. You can actually see it everywhere in Hawaii. But definitely, this Mumu is pretty as well. Today, pretty Mumu is not talking about Hawaii. Mumu actually will teach you how to count. That's easy. Everyone can count. But what if Mumu asks you to count from 1 to 1 million, one by one? How long do you think it would take you to do that? 1 day, 1 week, or 1 month? Actually, the fastest record in the world for a person to count from 1 to 1 million is 3 months. More accurately, it takes him 89 days to count to 1 million. Wow! Counting is easy, but counting one by one is really time-consuming. In the process, you have to always keep yourself accurate. No skipping, no overcounting. That's hard. So this time, Mumu will use 2 lessons to teach you how to count. We will use some powerful counting method to help us to count quickly, efficiently, and accurately. In the meanwhile, counting method can really help us to become a more patient and also detail-oriented person. Those qualities are super important and as a cornerstone for us to learn more complicated problems in the future. Although today we are the online class, but before the class officially begins, Mumu needs to emphasize on several class rules. If you're right now using Zoom to engage this class, please open your camera so that you can say hi to me. Yeah, wave your hands. Great. Let's try to engage. So right now, get your handouts ready, pencil ready, and scratch paper ready. Try to write down the notes and doing the practice together with Mumu. Also, while seated, put your toys away. Now let's start to pay attention and explore the math challenge together with Mumu. Are you ready? I see some of you already well seated. Great job. So let's start. First of all, do you love strawberries? Raise your hand. Mumu also loves to eat strawberries, but not only eating strawberry, but also picking strawberries. So Mumu went to a very large strawberry farm and picked a lot of strawberries shown as the picture here. Can you help Mumu to count how many strawberries did I pick? That's not hard, right? How about this? I will give you 1 minute. Can you try to count by yourself first? Great, let's do that. So, I'll just give you 1 minute. Okay, let's start. Now, time's up. So can you tell me how many strawberries did Mumu count? Did Mumu pick? Show me your finger. There are 30. Great. Let me just write the answer here. It should be 30 strawberries. If you didn't get this answer or you haven't finished yet, no worry. Mumu will count together with you. Okay, and where should we start? How can we count like this? 1, 2, 3, 4, 5, 6, 7. Can we do that? Nice, definitely we can do that. But if we count randomly, it's very easy to lose track. We can't remember which one already counted and which one we didn't. So when we count, we always try to count in orders. So which order do you prefer? How about this? Let's try to count from top to bottom, from left to right. Let's start from the top row. Let's count together. There are 1, 2, 3, 4, 5, 6. How many? Show me your fingers. Yeah, we have 6 here. Let's mark a little 6 here by the end of the row. Okay, can we continue? Yes. 7, 8, 9, 10. Wow, definitely we can continue to count like that. But did you notice any patterns? Yes, these strawberries are neatly arranged by rows. Great. And also, every single row seems like have same amount of strawberries. Let's double check. So for the second row, let's count. 1, 2, 3, 4, 5, 6 again. Great. Let's mark little 6 here. So since every single row have the same amount of strawberry, we can simply mark 6 by the end of each row. Now, after we mark every single row, what should we do? Yes, we need to make the formula to add them together. Great. So, this time we just say 6 plus 6 plus 6. How many 6 do I need to add together? There are 1, 2, 3, 4, 5. Great. So 5, 6 adding together. The total number is 30. Great. For younger kids, it might be a little bit hard for you to calculate this long formula. No worry. You can write down on your handouts first, and then you can take some more time to calculate by yourself. Now, is this formula looks a little bit similar? Oh, it's familiar for us, right? We are having 5 same numbers adding together. Is there any operation we can use to simplify the process? Yes, multiplication. Great job. So there are 5, 6 adding together. We can write as yes, 5 times 6 also equals to 30. Great job. So this time we just count by rows. Is there any, can we just count in other orders? Definitely. How about this? This time, let's try to count by columns and also from right to left. Can we do that? Let's try it out. I just changed another color. So let's count. 1, 2, 3, 4, 5. Let's mark a little 5 here. How about this line? It's also 5. Oh, how did you get it? Yes, we can say that every single column also have the same amount of strawberry. Let's always double check. 1, 2, 3, 4, 5. Great job. So for this column, we also have 5 strawberries. Actually, every single column have the same amount of strawberry, which is 5. Now, what should we do? Yes, sum them up. Let's write down the formula, which is 5 plus 5 plus 5. How many 5 should we add together? 1, 2, 3, 4, 5, 6. Great. There are 3 more, 5, 1 more. Total 1, 2, 3, 4, 5, 6, 5 adding together. Final answer is also 30. Again, since we're adding the same number together, we can always use multiplication. Great. So there are 6, 5 adding together. So it's 6 times 5 also equals to 30. Great job. So actually for this counting strawberry question, we count by rows. We also count by column. In the meanwhile, we can use the multiplication to simplify the process. Wow! But no matter what, in which order we count, we always count in orders. And while we count, there's one thing super important is mark in sequence. We mark down so that we won't lose any track. Great! This one sounds not that hard, right? Now, Mumu will give you a little bit bigger challenge. Are you ready? Let's go. This time, Mumu went digging for treasure and found a large treasure chest hidden in my backyard. I'm so lucky. Next time, probably you can try by yourself as well. According to the pile of the treasure shown here, we need to find out how many goldenrods did Mumu find. Can you try? Wow, seems like quite a lot, right? And also notice, what does this mean? There's a black hole inside. It means that some of the rods are missing or removed. There's no goldenrods in the middle. So when we count, we should be especially pay attention to this part. Don't count the empty part. Great. So, where should we start? Can we count one by one? Definitely, we can count 1, 2, 3, 4, 5, 6. Definitely, we can count just continually like that, one by one. And when you count one by one, it's better for you to count in an order. You can start from the top, or you can start from the here or here. But no matter what, remember always count in order. And also, better use a pen or your finger to point or mark it. Otherwise, it's a little bit easy for you to lose track. But we know that count one by one is really time consuming. So, is there any other way for us to count? Remember, how do we count strawberries? Strawberries, we count by rows and also columns. Here, for this large pile of goldenrods, they are also piled by layers. Great! So in this way, we can also count by layers. Nice! Let's try to do that. Okay, great. Oops. Okay, now, let's start from the top. That will be a little easier. How many goldenrods in the top row? 1. Great. Let's just mark a little one here. How about the second layer? 1, 2. Great. There are 2. So next time, show me your fingers. How many in the third row? Show me your fingers. 3. Nice. Just mark 3 here. How about next one? 4. Wow. Wait for a second. Any patterns here? Yes, when we add one more layer, we also add one more rod. So, next one, guess the number. How many goldenrods we have in the 5th row? Let's try 5. Can we? Let's try 5. Count it out. 1, 2, 3, 4, 5. Oh, right. That's the pattern. Great job. And how about the 6th row? Should we mark 6 here? Oh, I see some of us say, no, you're shaking your head. Why? Oh, they're black here. We are missing some. So in 6th row, we only have 1, 2 here. So, wow, you guys really pay attention to details. So, actually, in the 6th row, there are only 2 here. How about the next one? Show me your fingers. 4. Let's continue. How many in the next row? 6. Great. We need to double count, right? We need to just pay attention when counting. How about next one? 8. Great job. Last row. 10. Nice. We just mark out all these numbers here. And what should we do? Yes, we need to sum them up. Great. So let's try to list out the equation. The formula here is 1 plus 2 plus 3 plus 4 plus 5 plus, yes, it's 2 here, plus 4 plus 6 plus 8 plus 10. So total is, wow, that's a lot. I know if I give enough time for you, you definitely will calculate it out. But adding numbers one by one is really time consuming. Now, Mumu will teach you a little bit quicker method. There are a lot of numbers. There are good friends in these groups. Who are good friends together? Yeah, they are good friends if they can make tens. Great. So, for this one, for number 2, who's the best friend of 2? 2 plus which number can be a 10? Yes, it's 8. Great. So, if they are good friends, let's just find good friends of 2 and 8. We can link them together so that they can go hand in hand. Nice. So let's mark a little hint 10 here. And for number 4, who's the best friend of 4? Yes, show me your finger. Yes, 6 here. So we just connect them as well. And we mark 10 here. Is there anything else? Any good friends here? That group is hidden. Mumu will introduce this special group to you. It's 1, 2, 3, 4. Wow, this is a special group. 1, 2, 3, 4 adding together, they are also make a 10. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Great. So we just say it's 10 here. Wow. Next time when you see 1 plus 2 plus 3 plus 4, probably you can just immediately get is equals to 10. Nice. And also, don't forget, we have a 5 here. We have a 10 here. Oops. And always try to circle out all those single numbers. Otherwise, it's really easy to get forgotten. Okay, now it's easier for us to count tens, right? So there are 10, 20, 30, 45. Great. So we just got the number 45. So we just write the answer here. 45 goldenrods. Great job. Nice. But is there any other way for us to do it? Just remember, when we count by layers, we find out that there's a pattern there. When we add one more layer, we have one more rod. But it stopped here because we got something missing. What if we put them back? There's a full pile of goldenrods. And then we just minus the part we removed. Then it's also easy for us to get how many left, right? Yes, can we also do that? Let's try it out. This time, while we count, let me just change to another color. How about this pink one? Okay, nice. So, we just count. It's easy. 1, 2, 3, 4, 5. How about this one? How about the 6th line? If it's a full pile, just consider it's a full pile. Yes, it will be 6 here in the 6th line. And then, continue. Guess what's the next? 7. Great. So we just continue to write 8, 9, 10. We just assume all the rods already been filled back. Great. So In this way, it's easy for us to get the total full rods. It will be 1 plus 2 plus 3 plus 4 and plus 5 plus 6 plus 7, 8 plus 9 plus 10. Wow, there's another long formula here. But we already know how to find good friends here. So, can you try to use this good friends method to calculate this long equation by yourself? Let's try it, right? Okay, great. I'll give you 1 minute. Okay, just to take reference of what we just did here, connecting and finding good friends together. Okay, you can do it. Okay, thumbs up. This time, have you already found all the good friends? What's the total answer? Yes, it's 55. Great. Oops. How did you get it? We can find good friends together and just link them so that they can go hand in hand. So, one's good friends is 9. Have a 10 here. 2's good friends is 8. Have 10 here. And 3, we need to connect with 7. And 4, we got 6. And also do remember, we have a 5 left and we have a 10 left. So total we have 10, 20, 30, 40, 50, 5. Great, you all made it. So after we find the total full rods, oh my gosh, it's really bad writing. Let me just try to fix it a little bit. It's total full rods. Okay. Need to connect 7, connect. Okay, great. Got it fixed. So, we just got the total full rods. Is that answer we need to get? No, because we just filled what has been removed and put it back. Now, in order to get the total number of this pile, we need to minus what part is already being removed before. So, for this black hollow, how many rods do we have? They have how many layers? 1, 2, 3, 4. Great. So if it's 4 layers, it's really easy for us to get 1 plus 2 plus 3 plus 4 equals to how many rods? Yeah, take a look of this special group of good friends. So they can be a 10. Nice. So we need to mark this is a removed part is 10. Then the final answer is 55. Need to minus how many we have already removed so that we can get 45 left. Great! So we actually use another method solve this problem. But is there anything else we can do? Dingle, 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 dingle. Think about it. Is there any other way we can do it? Let me give you some hint. Take a look of this shape. What does this large pile of goldenrods looks like? What shape it is? Yes, it's a triangle. Great, so it's a large triangle here. And then this black hollow actually divided this large triangle into 3 smaller parts. What shape can you find? Yes, there are 3 small triangles inside. Oh, you didn't find it? Let me mark it out so that you can see it clearly. So this is a triangle 1, triangle 2, and triangle 3. So actually, this large pile of goldenrods can be divided into 3 smaller parts. Most importantly, let's try to compare these 3 different parts. And we can find that for this triangle, it has 1, 2, 3, 4, 5 layers. And this one has 1, 2, 3, 4, 5 layers. 1, 2, 3, 4, 5 layers. Wow! So for triangle 1, 2, 3, they are the same. Great! So this large pile of goldenrods can not only be divided by 3 parts, but also divided into 3 identical parts. In this case, we do not need to count how many in the large pile of the goldenrods. We only need to find out how many in the small piece, and then we can simply duplicate it using multiplications to calculate how many in the total large goldenrods. Right? Let's do it. So we can just move this smaller part out. We can say that we can see there are 1, 2, 3, 4, 5 layers. So mark it out. 1, 2, 3, 4, 5. So total for this little pile of goldenrods, how many rods will we have? Simply is 1 plus 2 plus 3 plus 4 plus 5. How many? 10, 15. Because we know, again, this is a group of friends. They are making tens. 10 plus 5 equals to 15. So it's very easy to get the answer of this goldenrod, this smaller pile. Because this one is the same as number 1, number 2 piles. So we can just use 15 times, we can just use 15 plus 15 plus 15. But also we can use, there are 3 15s adding together. So 3 times 15 equals to 45. Great! Wow! For this problem, we use 3 different ways to solve it. Great job! Just to give you guys congratulations! In math problems, it's always important to explore different ways to solve the same problem so that we can think in different ways. Nice. But no matter what, how we count, they are always the same counting principles. They are count in orders, no matter from top to bottom, from bottom to top, no matter what, we just count in orders. And secondly, mark in sequence. Always remember to mark it down so that you never lose track. And if you find identical pattern, it's always better for us to use multiplication to simplify the process. Great job! So, remember, this is very important counting principles. Now, it's your turn, and we will use this practice to try out whether you can remember all these counting principles and apply this method. Now, for this pile, Mumu already gave some pile to my brother and left some goldenrods here. It's your turn to calculate how many goldenrods are left and try to refer to what we just learned. You can definitely take a look of your notes and do it by yourself. Now, I'll give you 3 minutes. Okay, great. Let's start. Great, time's up. So, did you get it? How many goldenrods here? Yeah, you can actually get your handouts right in front of the camera so that I can see it. I see many of you have very beautiful marks there. Great, the total answer is 28. How did we get it? Let's just count together. Okay, nice. So for this goldenrod, let's just count by layers. So for the first one, there's 1. Let's just mark little 1 here. And how many in the second layer? 2. Great. Show me your fingers. How about the next one? 3. 4. Nice. How about next one? 5. 6. And 7. Great. So we just simply add them up, which is 1 plus 2 plus 3 plus 4 plus 5. Oops, I'm skipping here. So we need to 5, 6, 7. So the total is, again, we can quickly find some good friends here, which is 3 and 7 and 4 and 6. And we have 5 left, 2 left, 1 left. But it's really easy to count. 1 plus 2 is 3. 3 plus 5 is 8. So 10, 20 plus 8. So it's 28. But we can just write it down so that we can be more clearly. That'll be 10 plus 10 plus 8. So total is 28. Great. Did you do it like this? Nice job. So next time, always remember to count in order and mark in sequence. It seems like all you guys already mastered this counting method. Congratulations. I know you have been sitting there for a long time. How about this? Stand up. Everyone stand up, stand up. Let's just doing some fun games. Doing like this. Yes. We are so tired sitting there and doing the practice, and math is hard. But now let's do this. Let's do some finger games. There's a rabbit says okay. There's another rabbit says okay. Well, can you do that? Change hands. There's another rabbit says okay. Can you do that? Try. Yes, let's do it slowly. There's a rabbit says okay. There's a rabbit says okay. Another rabbit says okay. Ooh, can we do that? Can we make it quicker? Yes, a rabbit says okay. A rabbit says okay. A rabbit says okay. Great. Great job. Oh, you haven't messed it up yet. Oh my gosh, I already messed up. It's too fast. So definitely, it's always good for you to, exercise your fingers. Because you are holding the pen for a while. Yeah, we can just make our fingers more flexible. Great. So you can definitely make practice. Actually, it's not that hard. Rabbit says okay. You will find that this middle finger never change. So we just need to change all other fingers. So practice a little bit more. And definitely you can show that to your parents. Tell your secret. They probably don't know how to do it. They also need time to practice. So that you can just show them there. Great. So is it fun? Nice, nice. So right now, please sit down. We need to continue in our class. Great job. And now, Mumu disappeared. Where is Mumu? Where's teacher Mumu? Actually, Mumu becomes a baker here. Oh my gosh, she baked a super cute cube cake. It smells good. Do you want to try? Great, but here we are not eating this cake. We are using the cube cake to build cake buildings. So, for this cake building, how many floors do we have? If we just use one cube cake as one floor building, how many floors do we have? Show me your fingers. Yeah, there are 2. So, this is a 1. This is another 1. Great, very obviously. So let's just mark a little 2 here on top. So, how about this one? Wow, for this cake buildings, how many cake do we have? Show me your fingers. I see some of you say 3, and some of you say 4. Whether it's 3 or 4, let's try to find it out. Now, for this one, how many floors does this building have? Only 1, right? It's very obviously, so let's just mark little 1 here. How about this one? Yes, it's also 1. And then, for this one, on the second floor, should we mark 2 or 1? Actually, it's 2. But why? We can only see 1 here. Why we just mark a 2? Quick question. Can a cake float in the sky? For this cake, if I don't have a plate, can this cake just stay in the air? No, it can't. It will just drop on the floor and we have nothing to eat. Right, so there's no floating cake in the air, which means that for this second floor cake, it definitely has something underneath in the first floor to support it. So for a second floor cake, it definitely represents a 2-floor building. So we just mark 2 there. Total, how many do we have? 1, 2, 3, 4. So we total have 4 cakes. Great. And so for that one, it's a little bit easy. How about this one? Wow, we have a much more complicated cake building, right? And then how many cubes do we have in total? No worry. Let's just try to count. Remember how to count? Always count in orders and mark in sequence, as just what we did to count the cakes. So let's still mark it out. This time, we try to count from the lowest floor to the highest, from left to the right. So for this first cube, how many floors does it have? There's only 1, right? Very obviously. Great, let's just mark 1 here. How about this one? Yes, it's 1, 2. Great. And then next, this one? We definitely marked 2 there. Remember, no floating cube in the air. So if it's on the second floor, it represents a 2-floor building. So we just mark 2 there. And how many 2-floor buildings do we have in total? How many can you see? There are total 3. So there's another one. And this is the third one. Great job. Then for the last one, how many floors does it have? I have 3 in total. Great job. So again, since we just list out all the floors, next step we need to make the formula and do the calculation. So for 1-floor building, we total have 1 plus 1. We can also say that we have 2 1-floor buildings, and each of them have 1 floor. So total, in both ways, we can get 2 here. And for 2 floors, to 2-floor building, we have 2 plus 2 plus 2. Yeah, we have 3 2-floor buildings there. So we can also say we have 3 2-floor buildings, and each one have 2 floors. Total, we got 6 here. And for 3-floor buildings, it's very obvious we don't have 1 here. But also, we can say that there is 1 3-floor buildings. Each one have 3 floors. So total is 3. So total cubes we can have 2 plus 6 plus 3, which equals to 11. So how many blocks? There are total 11 of them. Great. Wow, we just found out that actually, although we're counting the cube, but actually we are using the same counting principles, which is count in orders, which we just count from lowest building to the highest, from left to the right. And also mark in sequence. We always mark the floor numbers on top of the building. Let's pause a little bit here. Why Mumu always mark the floor numbers on top of the building? Why? Let's pay attention here. It's super important. For a building, it may have different sides. We may see its front, we may see its side. But for every single building, it only have 1 top. So if we just mark the floor numbers on the only top of the building, we won't miss anything. We won't overcount anything. Great. So when we mark and count the cubes, it's always important for us to mark on top of each building. Great. So we have to go over counting strawberries, counting goldenrods, and also counting cubes. What's the takeaway for this? Counting orders. No matter what subjects we count, whenever we count, we try to count in an order. And also, while we count, we need to mark in sequence. Otherwise, it's very easy for us to get lost. And also, when we mark, try to mark smartly. For example, when we count cube, mark on the top to avoid duplicates. And sometimes, if you find identical pattern, for example, the same number of rows, every row have the same strawberry, and also the rows have divided to, yes, 3 identical shapes. All these kind of identical patterns, we can try to use multiplication to simplify the calculation process. Great, that's all we learned today. And Mumu has a homework for you. Wow, this is a much more complicated cube building. There are a lot of cubes there. Try to use the counting method and counting principles and to try to count in order and mark the floor numbers on top of it. This homework is also written on your handouts. You can open that, try to do by yourself, and you can show me next time. Great! In the meanwhile, and Mumu also have the WeChat group and also WhatsApp group for Think Academy. You can take a picture, or if you have the phone, you can just directly scan and join the group. If you have any questions for today's lesson or this homework, just find Mumu there. If your parents not there, you don't know how to scan this, it's fine. Just take a picture or a screenshot for this page. In the meanwhile, do you want to try what is the real class at Think Academy looks like? Wow, we have the classroom like this. And also we have our own learning app. Do you want to try that? Great. If you want to try, you can also download Think Academy app. How to do it? Download it and sign up. Then you just select your incoming grade in the summer. And then just choose the trial class and register. That's pretty simple. If your parent is next to you, you can ask your parent to do it right now. Otherwise, you just simply take a screenshot or take a photo of this and show that to your parents. And looking forward to see you in the trial class and also see you in the next counting lesson. Do remember to finish your homework and we can double check what you have already learned in next lesson. Great, that's all for today. See you next time.